unprecedented planetary anomaly, NASA's latest discovery. A phenomenon unfolding, NASA discovers a global magnetic mystery emanating from Earth's depths. In an unprecedented development, NASA has unveiled a significant planetary anomaly that is spreading across the globe, originating from mysterious forces beneath Earth's crust. This anomaly, known as the South Atlantic Anomaly, SAA, is a region of weakened magnetic field intensity that poses risks to space technology. But here's where it gets controversial. Some experts believe this could be a precursor to a magnetic pole reversal, a theory that has sparked heated debates in the scientific community. The SAA, a region of reduced magnetic intensity, spans parts of South America and the South Atlantic Ocean, presenting a significant challenge to satellites and space missions. As this anomaly dynamically evolves, drifting northwest and splitting into two lobes, it complicates satellite operations and exposes them to energetic protons, risking system malfunctions. NASA, along with other space agencies, is closely monitoring the SAA and using satellite data and core simulations to model the magnetic field evolution, enhancing mission planning and safeguarding our space infrastructure. The origins of the SAA are closely tied to the geodynamo, a process involving the movement of molten iron and nickel in the Earth's outer core, which generates the magnetic field. This field generation is influenced by several factors, including the tilt of Earth's magnetic axis and the presence of the African Large Low Shear Velocity Province, a massive dense structure located about 1,800 miles beneath Earth's continent. These elements contribute to a local polarity reversal, weakening the dipole field intensity in the region and creating the unique conditions observed in the SAA. The SAA poses considerable risks to space technology, particularly satellites that pass through this vulnerable region. These satellites are exposed to high levels of energetic protons, leading to single-event upsets, SEUs, that can cause temporary malfunctions or data corruption. In severe cases, critical systems might suffer permanent damage. To address these challenges, satellite operators implement strategies such as shutting down non-essential systems while traversing the anomaly. The International Space Station ISS, which crosses the SAA with each orbit, employs protective shielding for astronauts, though external instruments remain susceptible to glitches. The SAA is not a static phenomenon. Recent observations reveal dynamic changes in the anomaly's behavior. The SAA is slowly drifting northwest, expanding in area, and has begun splitting into two lobes, each with its center of minimum magnetic intensity. This bifurcation increases the complexity of managing satellite operations as more regions become hazardous for spacecraft. Scientists are tasked with developing predictive models of geomagnetic conditions to ensure the safety of current and future missions. NASA and other research organizations are committed to understanding the SAA's evolution through a combination of satellite data and core simulations. By feeding these inputs into global models like the International Geomagnetic Reference Field, IGRF, scientists can track the magnetic field's evolution and refine predictions. This approach is vital for planning space missions and understanding Earth's internal dynamics. Importantly, experts assert that the SAA is not an indicator of an imminent magnetic pole reversal, a rare event occurring over hundreds of thousands of years. As the South Atlantic Anomaly continues to evolve, the scientific community remains vigilant in its efforts to understand and mitigate its impact. With its potential to disrupt satellite operations and influence our understanding of Earth's magnetic field, the SAA poses intriguing questions about the future of our planet's work. Magnetic dynamics. How will these changes shape our technological and scientific pursuits in the years to come? And this is the part most people miss. The SAA's evolution could also provide insights into Earth's core processes and the dynamics of its magnetic field, offering a unique window into the planet's inner workings. What are your thoughts on the South Atlantic Anomaly and its potential impact on space technology and Earth's magnetic field? Share your insights in the comments below. The growing anomaly in Earth's magnetic field. Imagine a silent threat lurking high above, invisible to the naked eye, yet growing stronger every day. This vast anomaly, hovering over South America and the South Atlantic, is reshaping Earth's magnetic defenses in ways we're only beginning to understand. For decades, scientists have detected a peculiar flaw in our planet's magnetic field, a seemingly static feature that's now expanding and dividing, creating a significant weakness in our cosmic shield. Earth's magnetic field acts like an invisible bubble, safeguarding us from harmful solar radiation. This protective layer, generated by the swirling motion of molten iron deep within the Earth's outer core, is crucial for maintaining our stable atmosphere, enabling satellite communications, and even producing the mesmerizing northern lights. However, this field isn't perfect. It's influenced by various factors, including a massive underground structure beneath Africa known as the African Large Low Shear Velocity Protons, LLSVP. This geological formation disrupts the magnetic field generation, leading to areas of reduced magnetic intensity, particularly in the South Atlantic region. Enter the South Atlantic Anomaly, SAA, often likened to a pothole in space. This expansive area, situated between South America and Southern Africa, experiences a dramatic weakening of Earth's magnetic field, making it the weakest point on our planet. As satellites traverse this region, they face a barrage of high-energy solar particles, which can cause equipment malfunctions, sensor resets, and data loss. The International Space Station, ISS, for instance, crosses through the SAA during every orbit, necessitating extra precautions for its sensitive instruments. What's even more intriguing is that since 2020, the SAA has begun to split into two separate zones, each with its own center of minimal magnetic strength. This development has caught the attention of NASA, which is closely monitoring the anomaly to predict its future impact on satellite operations and other technological advancements. Despite not directly affecting life on Earth's surface, the South Atlantic Anomaly serves as a powerful reminder of our planet's dynamic nature. Even its deepest and most hidden systems are subject to change, highlighting the importance of ongoing scientific research and monitoring. As we continue to study this phenomenon, one thing is certain: the South Atlantic Anomaly will remain a focal point for NASA's efforts to protect our technological infrastructure and ensure the safe operation of satellites in space. But here's where it gets controversial. Could this anomaly be a sign of broader changes in Earth's magnetic field, potentially leading to a complete reversal? Or is it simply a localized disturbance that won't have a significant impact on our daily lives? What do you think? Share your thoughts in the comments below. NASA's South Atlantic Anomaly, a deep dive into Earth's magnetic mystery. NASA is closely monitoring a significant anomaly in Earth's magnetic field. For many years, NASA has been observing a peculiar anomaly in Earth's magnetic field, a vast area characterized by a notable decrease in magnetic intensity. This unusual region stretches across the skies between South America and the southwestern coast of Africa. This expansive and evolving phenomenon, known as the South Atlantic Anomaly, SAA, has captured the attention and concern of scientists, particularly those at NASA. The agency's satellites and spacecraft are especially susceptible to the diminished magnetic field strength found within this anomaly, which exposes them to charged particles emitted by the sun. The South Atlantic Anomaly is often described by NASA as a dent in Earth's magnetic field or a pothole in space. While this anomaly does not pose a direct threat to life on Earth, it significantly impacts orbital spacecraft, including the International Space Station, which traverse this region as they orbit the planet at low altitudes. When these spacecraft pass through the anomaly, the weakened magnetic field can lead to malfunctions in onboard technological systems, particularly if they are hit by high-energy protons from solar activity. Although these encounters typically result in minor glitches, there is a risk of substantial data loss or even irreversible damage to critical components. This potential for harm necessitates that satellite operators frequently shut down spacecraft systems before they enter the anomaly zone. One of the reasons NASA is diligently tracking the SAA is to mitigate these risks in space. Additionally, the mystery surrounding this anomaly presents a valuable opportunity to explore a complex and not fully understood phenomenon. NASA's extensive resources and research teams are uniquely equipped to investigate this occurrence. Geophysicist Terry Sabaka from NASA's Goddard Space Flight Center explained in 2020, the magnetic field is actually a superposition of fields from many current sources. The primary source of this magnetic field is believed to be a swirling ocean of molten iron located thousands of kilometers beneath the Earth's surface in the outer core. The movement of this molten mass generates electrical currents that create Earth's magnetic field, although this process does not appear to be uniform. A significant reservoir of dense rock, known as the African Large Low Shear Velocity Province, lies approximately 2,900 kilometers, 800 miles below the African continent. This geological feature is thought to disrupt the generation of the magnetic field, contributing to the pronounced weakening effect observed in the SAA, which is further influenced by the tilt of the planet's magnetic axis. NASA Goddard geophysicist and mathematician Weijia Kuang noted in 2020, the observed SAA can also be interpreted as a consequence of the weakening dominance of the dipole field in the region. He elaborated that a localized field with reversed polarity is growing stronger in the SAA area, resulting in the field intensity that is significantly weaker than that of the surrounding regions. Recent satellite data indicates that the SAA is not only drifting, but also appears to be splitting into two distinct cells, each representing the separate center of minimum magnetic intensity within the larger anomaly. This discovery raises intriguing questions about the future of the SAA. Interestingly, evidence suggests that the South Atlantic Anomaly is not a recent phenomenon, but rather a recurring magnetic event that may have influenced Earth for as long as 11 million years. This finding implies that the SAA may not be a precursor to a global magnetic field reversal, which is a process that occurs over hundreds of thousands of years. A more recent study, published in 2024, has also indicated that the SAA affects auroras observed on Earth, adding another layer of complexity to this already fascinating anomaly. While many questions remain unanswered, it is reassuring to know that NASA, the world's leading space agency, is closely monitoring this vast magnetic quantity. Terry Sabaka emphasized the importance of continued observation, stating, even though the SAA is slow-moving, it is undergoing changes in morphology. So, it's crucial that we maintain ongoing missions to study it. This is essential for developing models and making predictions. An earlier version of this article was published in August 2020.